talk quantum. Let's start at quantum.
Yep.
Now, there's a lot of talk about harvest now and decrypt later attacks. How real is the risk? And what's the timeline?
Or how long is a piece of string?
I was waiting for that.
So the risk has been articulated by the Australian Signals Directorate. So last September, ASD, which is the Australian Cyber Division, published a recommendation that called out from their perspective what the risk was. They're basically saying that all Australian organisations by 2030 need to have their operation quantum resistant and quantum secure.
Is that aggressive enough?
That's the ASD recommendation. Okay, so then to your point, you then look at how aggressive that is, because what they're saying is they're presuming a 10-year window or life cycle for data. You create data now, you want to keep it secure for the next 10 years. Their estimate is that by 2040, they believe a quantum computer will be powerful enough to decrypt that data. So you work back 10 years, 2030 you need to be secure. Then they say 2026 is the year you start to prepare. 28 is when you start to convert your operation. 2030 you finish. To your point around how soon will that be, there's a lot of articles out there talking about research, interesting research, which I believe is going to bring that timeline forward. I've read some out there in the industry believe that quantum computers could be here as early as 2035. Some I've read it could be as early as 2032. We don't know ultimately when that point in time is, but what I think is recognized is that there's a lot of investment and a lot of effort going into building out quantum computers for the good, to support all the wonderful use cases that quantum computers can help with. But at the same time, for all the good, there's also the flip side of the bad. You build a powerful enough quantum computer or quantum setup that gives a threat actor or a nation state the opportunity to use it for bad purposes. And I think for many organizations, what I've come to appreciate is that there's a lack of awareness on this particular threat, which results in maybe not accelerating their preparedness to secure their operation for that.
So it's 2026 right now.
Yep.
Organizations are making investments in technology, and that technology lifespan, let's just assume it's 5 to 7 years. There's a good chance that the infrastructure purchased today is the same infrastructure that's still running for many organizations when quantum computing becomes real.
Yep.
And data starts to be decrypted.
Yep.
What do customers do today? You talked about being prepared. What do customers do today to actually prepare to take steps on that journey to protect themselves?
There's two areas that they need to focus. The first part is around encrypted data transport. So I'm sending some data from point A to point B, and I'm encrypting it. First order is to look at the cryptography options you're using to encrypt that data. The cryptography option will be deemed by ASD as either being quantum resistant or quantum vulnerable. If it is in the quantum vulnerable camp, there'll be a need to go in to the configuration and change the cryptography option you're using to secure the transport of that data.
So that's a software upgrade?
So that typically will be a software upgrade, which will then give you support for those new cryptography options, which you can then use to modify your configuration. So if you're doing MACsec or IPsec, for example, you go into the MACsec, IPsec configuration, you change from crypto option A to crypto option B, reboot the link, reboot the box, and you're now resistant, or you are now applying a resistance for the encryption of that data.
For transport.
Right. And that then has to apply across your organization, across your operation, wherever you're using encryption. That's the first one. That's probably the easy one. The more challenging one is called out a little bit deeper into the ASD article or the recommendation. And as you look across IT devices, not just Cisco, but everyone, there are going to be instances where firmware in that device has been signed and encoded by some form of cryptography.
I'm going to hold you. I'm going to pull you back there. There are going to be instances. How prevalent is that? How prevalent is a hardware-based limitation on terms of you need to upgrade your algorithms? Not a Cisco conversation, but across the industry.
Different devices, some devices do encode and sign that firmware, and digital certs are embedded into the components and into the software inside that box. Others don't. Within Cisco, we actually launched last year, June 2025, at our Cisco Live show in San Diego, 2 new lines of products, new Cisco 9000 switches and new Cisco 8000 routers. When you look at the fine print of those announcements, you find a couple of little lines in there that say that the firmware, specifically bootloaders and digital certs that are embedded into the hardware components, have been encoded, previously were encoded in older versions using the non-quantum secure crypto options. In these new platforms, we've encoded them using the new, more secure cryptography options. And so ASD is effectively calling out that if you're looking to make your operation quantum secure, likely there's going to have to be an audit of the devices, speaking to the vendors of the devices you've procured and asking them, are any components in here encoded? And if so, what did you use to encode? And if it happens to be an option that is not quantum resistant, what can be done to change that to make it more quantum resistant? And I think each vendor will have a different answer for that. But I think it's something that every IT operational leader is going to have to engage in that conversation. The starting order is to understand that audit of what is in your operation, what is secure, what is not secure, and then figuring out a plan to move forward.
Traditional data security has been focused significantly on sovereignty of data. But what we're seeing with the considerations regarding quantum security is that sovereignty needs to be expanded. The idea of sovereignty is a life cycle approach and an architectural approach where it's not about where the data resides, but it's where it's created, it's where it's stored.
Correct.
And obviously where it's and how it's accessed.
It is definitely expanding that view of sovereignty. Because to your point, you create data, you think about where is it hosted, where is it held, where does it go? And if it's within boundaries that are acceptable to the organization, you're all good. But now all of a sudden you're starting to talk about devices in your operation that are helping drive your business that have been encoded by someone that might necessarily be not local. And that obviously has implications for many CISOs. As I'm starting to speak to CISOs, that one there is, like, I think, opening their eyes a little bit, raising maybe the hair on their neck, and starting to think, okay, there's another angle I need to start exploring here to better understand what is going to be the risk to me. And ultimately it comes down to risk. If there may be aspects of your operation where it doesn't really matter, but some parts of it where it does. But generally speaking, I think the industry verticals that are looking at this more so right now, you're looking at financials, you're looking at government, defense, you're looking at critical infrastructure. They tend to be industry verticals that are paying more attention to this at this point in time. I think other organizations, as they start to appreciate this, will follow.